Magandang umaga everyone, magandang hapon everyone. Your lesson for today is about Unit 6, Lesson 9, using radians. So, for your warm-up today, we have the angle measures. It is only asking you which one doesn't belong. Why letter A doesn't belong? Write down in your green paper. A doesn't belong because it is the only angle that doesn't directly have its measure marked, which is correct. Of all the three choices here, the angle or the central angle is out. Okay. B. Why B doesn't belong? Because it is the only angle that measures greater than 90. As you can see, that would be 270 instead of 90. Now, why C is not doesn't belong? Because it is the only angle measured in degrees, which is correct, 51.5. Why D doesn't belong? Because it is the only angle measures that it is a whole number. Because this is measures in radian. Now again, this is for your Wednesday warm-up. Okay, what you are seeing right now is what you called the equivalency of degrees in radian. So degrees are 0, 90, 180, 270, and 360. Or was that? Here, a 0, a 90, a 180, and a 270. Oops, I can write and then 360. Now, if you're gonna go over the radian value, that would be a 0. I'll change my color. I hope I can change it. No, I don't know how. Yep, I don't know how. There you go. Okay, green. So that will be a 0. Same thing with degrees. The 90 will serve as pi over 2, while 180 is a pi, and then 360 is 2 pi. Alright, which is equivalent to 360. 360 and 2 pi. Alright? So, this is how it, I blocked it, but this is how it should be. 0, 90, and then pi over 2, 180, and then pi, 270 and 3 pi over 2, and 360 is 2 pi. Now, if you want to go check and play with applet, you will see much of this one. So, the entire circle is 180 in half, and then the full circle is 360, which is 2 pi. So 180 is pi. Alright? Now, degree versus radians. What is radian? It is an alternative way to measure angles. It is the measure of a central angle that intercepts an arc equal in length to the radius of the circle. Now, what does it mean? After this video that I am recording, you are allowed to watch this YouTube video from another teacher which explains why or how you will see radian in a circle. What we only see are degrees, but in this video you will see how to count or how many radians does a circle composed. Next, degree versus radian. Express each radian measurement in degrees. As you can see on top, the formula radian equals to pi over 180 times degrees. So, given that these are radian, you are making it into degrees. So, formula, why this is back? Hold on, let me erase it. How will I erase it? Erase. How will I erase? The here? No. Here? Oh, yep. Okay, so therefore, wait. I'll change my color. I'll make it blue. Okay. So pi over 180 multiplied by multiply by, again, I need to erase it. Again, we're gonna use degree because this is in radian. So, 180 divided by pi, multiply by pi over 3. So, this will 2 cancels out, and that whatever is 180 over 3. So, the answer is 60. Let's see if that's the answer. 60 and 225. Okay, let's create the other one. So, here, same thing. 180 divided by pi. Okay, divided by pi. Multiply by 5 pi over 4. So, pi will be cancelled. Pi will be cancelled. And that ends up with 180 times 5 over 4. So, if you multiply that, how much is that? Which is, I don't know. Hold on. I'm using my calculator. So, you have 180 times 5 divided by 4. 225. So that's 225. Okay, yeah, we are right. Right? That is correct. Oops. Now, for down there, you're gonna have 30 into radian. So, here, you're gonna use pi over 180 multiply by 30. These two will be cancelled out. That will be so this will be equal to pi over 60. Is that right? Yep. Oh yeah. It's only 6 because it's 180. Yep. So we are right. Next, 120. 120. Let's change color so you will see. Pi over 180 multiplied by 120 equals, that would be 120, and 180 is divisible by 6. So that gives you 60. So that will be, if that's divisible, that's 2. 180 is 3. So my answer is 2 pi over 3. Is that right? Yes, we are correct. Okay, next. So let me introduce you. Okay. This is the unit circle. The unit circle is composed of 3 layers. The layer inside are what you call the degrees. The layer outside, in the middle, is what you call radian. The one outside is what you call coordinates. Okay? Please remember that, because in some point, those are related to each other. If you're looking at for the value of 0, again, that would also be 0 in degrees. Now, if you're looking at that the value of this one is 360, and then the radian will be 2 pi. And the coordinates would be at 1, 0. So these are your locations, and these are the values of each of the degree that you are looking for. So in degrees, an arc length, let me erase this. An arc length in radian is this one. Now, again, these are both arc lengths. In degrees, it should be 360. In radian, it should be 2 pi. Okay? Now, if you're looking for the area sector, same formula that we used yesterday, theta over 360 is pi r squared. That's in degrees. Now, if you take a look for area of a sector, that would be theta over 2 pi instead of 360. This is in radian. I hope you understand this part. Again, these both are arc length. These are both area of a sector. Okay? Now, let's have an example. Oh, wait. This arc length is not simplified yet because, again, you can cancel out the pi, the 2, and the 2. So what only remains is what you called r theta, which is theta times r. So the simplified value of the second arc length in radian is theta times r. Now, in area of a sector, this is also not simplified. Why? This can be canceled. This would be canceled. So what remain only is r squared times theta over 2. So this would be the actual formula in finding the area of a sector in terms of radian. I hope you understand. So let me erase this one. Okay. Now, which side should the flower be placed on? So, as you remember the unit circle, you need to compare an angle measured in radian to an angle measured in degrees, which is bigger. Now, you may open your Desmos if you want and take and compare this one. So, pi would be 180, right? If it is in here. So, this is pi. So, 200 would be here. So, which one is greater? So, it's 200, right? So, the flower should be there. What about 3 pi over 2 and then 200? So, obviously, 3 pi over 2 will go more. Okay? If you take a look at them by the, what you call that? The unit circle, it would be up here. Yeah, some location. So, that will be in this side. So, this is bigger. Now, in pi over 3 radian, or 45 degree, so pi over 3 is bigger because 45 will just stay here in this part, while pi over 3 will be here. Alright, so the flower will be there. Okay, again, you can verify this in your Desmos graphing. Alright, next. This is a complicated one, so I want you to listen carefully. So again, in degree, the arc length is 2 pi r times theta over 360. In radian, the arc length is equal to pi over r. Okay, to start with, we need to use the formula in arc length in degrees. Okay, so therefore, what you're gonna do there is to read and annotate the problem. It seems like there's something that we need to verify. Okay, let's begin. So it says here that the circle have a central angles equal measure. So expect that this side is also pi over 6. So that would be, we're solving for x, right? In the circle shown, determine the value of the x. Let me change my color into darker so you will see. Okay, so that would be arc length is 2 pi r 2 pi r wait, what am I solving? Nope. Arc length in radian. Oh my god. Yeah, because since this is radian, I'm sorry. Again, so the formula would be theta over, times r. So your theta is pi over 6. And then your radius is 4. So if you multiply that, that would be 4 pi over 6. Get the lowest term of 4 over 6. You can type in Desmos. So that would be 2 over 3 pi, which is our answer. And verify that is true. For the second one, this is same thing. However, the arc length is given. So we're going to create an equation. We're going to have 4 pi over 3, which is the arc length here, equals to the theta. Theta is unknown, which is the x, times the radius 8. So you cross multiply this one. So therefore, that will be 4 pi over 24 is equal to theta. What's the lowest term of 4 over 24? That would be pi over 6. And that would be our theta, or the value of x. And that is our answer. Next, let me erase this one. Okay, in this case, in circle shown determine the value of x, figures are not drawn to scale. So, this is kind of like, let's see if I can explain that properly. Hold on. Okay, so at this point, we're gonna use the degree, since 70 is in degree form. So you're gonna use 2 pi r times theta over 360. I'm gonna go slower, but again, you can always watch this multiple times since this is a video. So you're gonna start with arc length is 7 pi over 5 is equal to 2 pi times the radius is x, which is we don't know. I'll put radius. Multiply by theta, which is 70 over 360. Now, if you put them all together, that becomes 7 pi over 5 equals 2 times 70 is 140. That would be pi, that would be r over 360. Next, so if you want to cross multiply them, that would become 7 times 360 pi over 5 times 140 pi equals r. So everything here is on the left side. 140 pi times 5 and then 7 pi 360. Okay, so you're gonna multiply that. You're gonna multiply everything together, and you're gonna end up with 18 over 5. Why? Cancel, cancel. Simplify everything. 760, 140, and 7. You can have 20. 360 divided by 20. You're gonna have, what's 360 divided by 20? 18. 18 and 5, 18. 360 divided by 20, cancel. So yeah, 18 over 5. So that's why the answer is 18 over 5. So that's 18 over 5. Okay, next. For the next one, letter D, you're gonna use the arc length. Why? Because it's in radian. So arc length is 2 pi. Let me change my color so it won't mess up. So that will be 2 pi over 3 equals theta, which is unknown, times 15, which is the radius, right? So cross multiply, that would be 2 pi over 45, right? 3 times 15 equals theta. So what's the answer? Yep. All right. That's the answer. If you have other questions, you may ask your current teacher right now or ask me tomorrow. Alright? Next, sector area shortcut.